Good morning, everyone. This is my third lecture in this unit, and this will be the last of the material before I give you a practice quiz in your quiz. Make sure every day you are checking the document. So this is, again, how we're going to operate. And so, again, you don't see the lecture yet and the sheet for the video lesson because I'm doing them right now. But check this every day for anything new. I posted yesterday 3 nice little short videos explaining things that will be helpful to you. So in my overhead back up here, we're going to end with the continuous growth and decay formula, which, yes, spells my last name, but it's not because of my last name. And I think I'm going to actually use the PERT formula today. And concept before we start in the notes, you have learned that you need a logarithm to solve an exponential. So what's an exponential again? An exponential is where we have variables in the exponent position, or we're interested in something in the exponent position. So in this formula, if you're solving for r or t, since they're in the exponent position, you need to do a log base e, because e is the base. What's e? The natural exponent, 2.718, so on and so forth. It's an established value like pi. You'll need to do log base e on both sides. After you divide out by t to get it in the form, this second line here, to get it in the form so that you're ready to do log base e. And this is really what our work is going to entail today. And then when you get to this step, divide by r or t to get the other one. The other calculation will just be after we establish the equation. That's why you see the a and the t highlighted. That's the y, if we were going to put it in our calculator and look at a table. And the t is the x. Those are the variables in the situation. And the p is the beginning quantity, which is a constant. Now, I know I say the word constant and great trembling and fear comes over you. It's not the word constant that's the problem, boys and girls. That just means a value that never changes. It's the type of problems that you saw in practice for the SAT, like on your PSAT, that involve the word constant. So it's the kind of problem that the word constant was in. E is a constant. I just mentioned that. And R is also a constant. So that'll be the rate of growth or the rate of decay. Kind of like a decimal, a percent converted to a decimal situation. All right. You'll need your calculator. Again, if you don't have a calculator, I'll show you how on just a search bar you can type in the computations that you need. And rounding is going to be a big thing with this. So we need to, when we solve for r, we need to round r to the nearest hundredths place. So if you don't round correctly, your answers will be a little bit off. And then I think all values of t and all values of a that we solve for will be rounded to the nearest tenths place. So I tried to be specific in the asking of the questions. So on this is your number 1 notes. These 3 we've studied quite a bit of, and now we're going to move to the continuous formula. So you have to see the word continuous somewhere. And yes, radioactive growth and decay, or radioactive elements, excuse me, involve the continuous formula. So steps, how does this work? What you want to do is to start off by writing this. Step 1. Step 2, put in what is given, and then we have to do the work. If we're solving for r or t, we have to do this work. If we're solving for a, it's just going to be a straight calculation. So there's 1 of 3 things you're doing. Solving for r or t, which is this work, and then you just divide by whatever one you need to isolate the r or the t. Or you're solving for a, which is just a straight computation. It's those possibilities. So initially 30 grams. So the P is 30. After 10 years, 20 grams. So this is what we have. Times E to the RT. That is step one. That's what we know. And now from here, we're going to do the work. We're going to divide by 30. And so we'll, again, there's rounding issues here. I know that to be 2/3 equals E to the, I didn't put 10 in, sorry about that. So 10 does go here for the time. Need you guys with me to catch my mistakes. That goes in for time. And now we want to get at the exponent position. Well, we've done a lot of this. So this has to be a log base E on both sides. Now I'm going to start writing ln. But hopefully you understand that ln is log base E. I've said it enough. I've done, if you've watched the videos, you should know it now. So that goes away. Log base E of E is 1. Now to get what R is, we're going to do ln of 0.6 repeating, which you can just call 2/3, divided by 10. And I want to emphasize, I'm going to show this one time, and then I'm just going to use my calculator. So let's call it 2/3. And then we're going to divide by 10. This is in an internet search bar. Negative 0.04. We want to round this to the nearest tens place. Now let me come back to my overhead. You can literally do that. The internet's a very powerful place to operate. That's our answer here. Now, it's very important that you understand this. Okay, I always want to write y. You can write y if you want. I'll write them both. It's very important that you understand this. 30 times e to the negative 0.04t. This is the equation. However you want to write this, you need to write that after you figure out r. Now what we do, okay, so this is our answer to, either one is our answer to part B, is we use that equation to answer questions. Find the half-life. Yes, there is a formula. You'll see why the formula works. And then find the amount of elements. So we're solving for t here, and then we're solving for a of t here. Remember, there's 3 things you can possibly do on these equations. Solve for t or r. The work looks like this. Then you just divide by the other one. You saw that on part A here. Or solve for a of t, which is just a y value given an x value. And then the y is the a of t, the x is the t. Find the half-life. So what does half-life mean? That means that half of your original amount is left. So here we go again. We got to get at the exponent. Divide by 30, well, that's 0.5. And now we got to do log base e. Well, what is log base e? Log base e is ln. And the exponent comes down. And log base e of e is 1. And now we want to divide by negative 0.04. And this will deliver our half-life, which is 17.3 years. Now I want to show you something. A formula for half-life is ln of 0.5 over r. It's always that. It's always that. Because no matter what your numbers are, when you divide, if this is half of this, you get 0.5. So you're always doing ln of 0.5 over r. And if you're in the half-life situation, has to be the half-life situation, this is what time the half-life equals. If you're given time for the half-life, you can figure out r. by just going the other way. So ln of 0.5 over the half-life time equals the rate. But you can always do the work too. That sounded a little confusing. So find the amount of element to the nearest tenth present after 50 years have elapsed. So now what we're doing is time is 50. So that goes in up there. Now, if you don't like, so you're just scratching this out, just use 2.718. Go to an internet search. Here we go again. And do your work. So 30 times 2.718, right, parentheses, raised to, you got to find that little, here, then you need to use parentheses, negative 0.04. Then you got to find the times, which is like the asterisk, times 50. Now, I'd hope you'd have a calculator. So this is how you'd enter a, let's see if this actually works. I'm a little bit in doubt here. Oh, wow, it worked. There you go. That's how to do a straight crunch. So 4.1 grams. That's how you do a straight crunch. For E, I use 2.718 raised to the power of negative 0.04, the asterisk key times 50. And that delivers 4.1. There's also the work you can do on your calculator. Okay, so keep that in mind. But I'm trying to show people that don't have a calculator how it's possible to do this work with an internet search. Next page. So we do have the rate here, and that's interesting. So once you have the rate, you need to write the equation. I'm going to do that up here. So we have 500,000 is the initial amount. Growing at the rate of 0.0375. Why 0.0375? Because you need to convert that percent to a decimal, and that is 0.0375. So there's our equation, and now we're going to answer questions. It's just one question on this. How long will it take to reach 1 million? So yep, you take 1 million equals 500,000 times e to the 0.0375t. And it's the work that I showed you with the little card. Somewhere, I don't know what I did with it now. All right, so you're going to divide by 500,000. That's going to be 2 equals e to the 0.0375t. Now you got to do log base e on both sides because we need to get at the exponent. What is log base e? It is ln. So 0.0375t times ln of e. So that comes down from the exponent position to go in front. This is 1. So t is ln of 2 over 0.0375. And what is that? 18.5. Just use an internet search bar. It will do it. It will. I just want to check real quick that 18.5, indeed it is. 3a, the half-life of phosphorus-32 is about 14 days. There are 6.6 grams present initially. Find R and write the equation. So you need to, when you do this, so we're finding R, which means we've got to do the, anytime you find R or T, you have to do this work that I had on the card. I'd find that sucker and what I did with it. Okay, you need to do that work that I had on the card when you're trying to find R or T. So half-life is 14 days. So there's going to be 3.3 grams left. Your A of t. P is your initial amount. Times e to the r times 14. So the time is 14. And now, same work. We can call this 14r if you want, or r times 14. You're going to do ln on both sides. So notice how, again, you have that ln of 0.5 for half-life. So r is going to be ln of 0.5 over 14, which is negative 0.05. Now, because there's no question asking us to write the main equation, you need to do that every problem. Now, up here, I just knew what r was, so I went right to it. That's part of the deal. I should have said also write the equation. Oh, I did. There. Okay, sometimes I don't. But you need that main equation. Now there's questions about your y given an x or your x given the y. And your x is the time value, your y is the amount present after so much time goes by. So how long will it take for 1.65 grams to be present? And same idea, we're going to divide out. That's 0.25. E to the negative 0.05 t. Now to get at t, we need to do ln on both sides. And that exponent comes down. That goes away, and now we want to divide both sides by negative 0.05. It should actually be, let me see here. It should actually be exactly 28. I get 27.7 because of rounding. That's the problem. Now, why did I say 28? Because you're just having, so 3.3 is the half-life, and then 3.3 divided by 2 is 1.65. So it's just another 14 days. It's a rounding issue with the rate when we calculate it. So rounding causes a little bit of error in these, just so you know that if you're trying to make sense of like half-life situations. So this is just another half-life from the first half-life, which means it's just another 14 days, and that should technically be 28. All right, so 1 gram. We're going to do 1 equals 6.6 times e to the negative 0.05. And then you're going to divide that through and work it out. And it's, this is 0.15 repeating. It's going to be goofy with some of the values that you get. Just go with it. Equals negative 0.05 t times ln of e. That's 1. And then divide by negative 0.05. So you can use, so when you get this, you can do ln of that answer divided by negative 0.05. You got to learn how to use your answer function. That's behind your negative key down here. When would you use your answer function? When your answer is not nice. And it's just in, so you would have it in your memory right there. You have to have it entered in. And then in the next line, you just do wherever you want to input the answer into whatever formula you go down and grab, you do second function answer, it will input it wherever you want it. So that's going to be pretty big if you're using your calculator doing this. So 37.7 days. All right, last page. Same idea over and over. we can write out, we're being reduced by 20%, and the initial cases are 10,000. So e to the negative 0.20. Be careful if it's negative, it's, you know, if you're reducing, it's negative, the r value. If you're increasing, it's positive. So how long will it take for you to go down to 1,000? So solving for t, which means we're going to be doing the natural log on both sides. This will be 0.1. And then ln on both sides. So we'll have ln of 0.1 equals negative 0.20t times ln of e, which is 1. And then divide by negative 0.20, and you'll have it. And that is 11.5 years. 8,000 cases remain to the nearest tenths place, so we're going to solve for time again when this is 8,000. E to the negative 0.220t. I'm wondering if there's some pattern that we could use. Probably not. 0.8. And then same work. Anytime you're trying to get at r or t, you have to do ln on both sides. And that's going to bring down that exponent. That'll be 1. And so t is going to be ln of 0.8 divided by negative 0.2. And that'll be 1.1 years. You have to make sense of things. So only 8,000 cases, that's not very much time going by. Down to 1,000, that's a lot more time that needs to go by to get there. So you do need to make sense of all of it. Find the half-life. So we're still in the same problem. So when you're still in the same problem, you use the same equation. Now, maybe you know this is going to be ln of 0.5, and you're ready just to go there. ln of e goes away, and that exponent comes down. That's the whole concept of logarithms, to pull an exponent down. Whether you're graphing or solving a problem, that's what they do. And now you divide by negative 0.2. And that is 3.5 years. Interesting question to end with. How long will it take to eradicate the disease? So you can't use 0, because if you use 0, you're gonna add an error. You can't take log of 0. And there's reasons according to the definition of logarithms why that's true. I'm not going to talk about that right now. You got to choose 1 and then just say your time has to be greater than it would take to get down to 1. Obviously, if just one person has it, you're really close to eradicating. So there's what you would do. And then 1 over 10,000, which is going to be 0.00001. So it's the same work over and over to get at r or t. So this will be 0.0001. Yep, equals. And then ln on both sides. Ln of e is 1. And so time is ln of 0.0. So you see this pattern that exists when you do this, of how we end up here, of ln of that division over either the r value, usually it's the r value, but it's over a time value if you're solving for r. But it ends up like this all the time when you're solving for r or t. 46.1 years, so it's going to be a little more than that. But that's about what you would be looking at, because that's to get to 1K. So we want to get to 0. And you can't use 0 because you'll get an error in your calculator. All right, I'll end there. And tomorrow I'll post the quiz review with the solutions. I would advise you to do the practice quiz review without the video first. See what you know, and then go to the video. And then as far as the quiz on Monday, do it. I'm not going to post solutions. Just hold on to it. Take a picture of it. Hold on to it. And then at the end of this trimester, the 5 quizzes, I'll just say, hey, send me an email, and then you'll get your credit for the class. So this is just pretty much, I'm not going to grade anything. You're not going to get a grade. You're going to get a credit or no credit. So do your work, and you'll get your credit.